In this quick tutorial, I'll show you two examples on how to solve equations that contain sine. This is part 2 of this series. Question number 1 reads, solve the square root of 2 times sine 3x minus 4 is equal to negative 3 for x on the intervals 0 through 2 pi. The first thing that we'll do here is isolate for sine 3x. And to do that, we'll bring this negative 4 over, and we end up with the square root of 2 sine 3x is equal to negative 3 plus 4. Simplifying the right side, we end up with positive 1. And we also need to get rid of this on the left side, so we'll divide both sides by that. And if we do that, we end up with this on the right side and sine 3x on the left side. Now that we have this equation, we have to choose one of the special triangles that has both 1 and the square root of 2. The only special triangle that has 1 and the square root of 2 is this one. Here's a right triangle. This is pi over 4, pi over 4, pi over 2, and across from this is the square root of 2, across from this is 1, and across from this is 1. Furthermore, you'll notice that this ratio is positive, and sine is only positive in the first and second quadrant. Keeping that in mind, you'll notice that if we take either this or this as our reference angle, so let's pretend that we take this and we say that sine, which is opposite over hypotenuse, opposite is 1, hypotenuse is pi over 2, so therefore one of our angles will be pi over 4. Now, keep in mind something, that normally we have sine and simply x in the middle, but here we have sine 3x. So in this situation, what we have to do is we have to take pi over 4, this number, and we would have to make it equal to 3x. Solving for x would give us the correct angle. Now keep in mind also that sine will be positive in this quadrant. So to find out the angle here, we would take pi, which is half a cycle, and subtract it from pi over 4. And by doing that, we get our second potential angle. So let's do that right now. Make this over 1, find a common denominator. So multiply this by 4 and this by 4, and we end up with 3 pi over 4. So this is our second potential angle, and we'll also set that equal to 3x. That being said, to find out our actual angles, we have to isolate for this x and this x. So we divide both sides by 3. And if we divide both sides by 3, we end up with pi over 12 and 3 pi over 12, which equates to pi over 4. So therefore, this value and this value give us the correct x for this equation. Now that we've experienced one of these questions, let's try another one. This question, they ask us, solve 24 times sine 3x plus 19 is equal to 7 for x on the intervals 0 through 2 pi. So like we did before, we're going to solve for x. We're going to bring this over, and we end up with 24 sine 3x is equal to 7 minus 19. 7 minus 19 is equal to negative 12. And here we have 24 sine 3x, dividing both sides now by 24, and we end up with, over here we end up with negative 1 over 2 sine 3x. Now, sine, as suggested in the previous example, is positive here, and it's negative here and here. Also, sine is opposite over hypotenuse. So this right here represents your opposite, and this right here represents your hypotenuse. Now, which special triangle relates 1 and 2? If you recall, the 60, 30, 90 triangle, or in other words, the pi over 3, pi over 6, and pi over 2 triangle, here we have 2, here we have the square root of 3, and here we have 1. And so now we have to decide which reference angle, this one or this one, represents the following. Well, if we choose this, opposite is the square root of 3, and obviously that's not 1. So let's try this one. Opposite is this, it's 1, and the hypotenuse is 2, so therefore our reference angle in this situation is pi over 6. So let's write that down, just keep that in mind, pi over 6. Now I suggested earlier that sine will only be negative here and here. Now that we have our potential angle, we can actually find this angle, and we can find this angle. To find this angle, what we're going to do is take pi and add it to pi over 6. And if we do that, we end up with, well, we need a common denominator first. We will end up with 7 pi over 6. So this angle right here, this one, is 7 pi over 6. To find this bigger angle, what you'll have to do is take 2 pi, which is one complete cycle, minus pi over 6, that reference angle. And once again, we're going to find a common denominator, multiply the top and the bottom by 6, and we'll end up with 11 pi over 6. This bigger angle is equal to 11 pi over 6. But now keep in mind that we don't have sine x or sine theta. We actually have sine 3x. So what you're going to have to do next is take this angle and make it equal to 3x, and then subsequently solve for x. So let's do that one step at a time. And then subsequently solving for x by dividing both sides by 3, we end up with x is equal to 7 pi over 18. And similarly, we're going to do the same thing, but for this angle, we're going to take 3x is equal to 11 pi over 6. Dividing both sides by 3, we end up with 11 pi over 18. So therefore, x is equal to this number and this number. Both of these will give us -1 over 2. So there you have it. 2 examples on how to solve equations that contain sine using special triangles. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.